So section 5.4 is the fifth and final way to prove that two triangles are congruent. So we already did SSS, SAS, ASA, AAS. Today is the fifth one, okay? It's the HL, or the hypotenuse leg theorem. All right, so we have a right triangle. Which side is the hypotenuse? AB. Yes, the AB, or the one across from the right angle, that's your hypotenuse. So first you got to start with a right triangle. A right triangle is a triangle with a right angle. The hypotenuse is the side across from the right angle. The leg is, there's two legs always. The legs are the sides that are the ones that make the right angle, okay? We talked about all this when we did Pythagorean theorem. A squared plus b squared equals c squared. So none of this is new. So here's where this comes into play with what we've already been looking at. You can prove that two triangles are congruent using the hypotenuse leg congruence theorem. The hypotenuse leg congruence theorem says that if the hypotenuse and leg of a right triangle are congruent to the hypotenuse and leg of a second right triangle, the two triangles are congruent. So anytime you see a right angle, you should check HL first. It might not be HL, it might be like side angle side or something if they give you both of the legs. But if you have one leg, one hypotenuse from one matching with a leg and a hypotenuse of the other, it's HL, okay? Any questions? Example 1 says, is it possible to use HL congruence theorem to prove that the two triangles are congruent? So basically, does HL work? So you need three things to use HL. You need right triangles. Do we have that? Yes, there's right angle in both. Do you have matching hypotenuses? Hypotenize. And then do the legs match? All right. So yes, both are right triangles, and the hypotenuse and one leg are congruent from one to the other. So this is a yes. Okay. Again, can we use HL? What's the first requirement of HL? Right angles. Do we have right angles here? That is as far as you need to go. No, these are not right triangles. It's like the bare minimum to even consider HL. The right triangles. Once again, is HL going to work here?
No, because it ain't got a right angle.
Hold on.
Yes.
But they can go.
No.
Hold on. Let me talk. I love how enthusiastic you all are. However,
But they both can go.
what type of line or angle do I have right here? JLM is what type of angle?
Straight.
It's a straight angle. I know that. That is the only angle measure you can assume from a diagram is a straight angle. Please stop. Okay? So if this is 180 and this one's 90, what does this one have to be? 90. Okay? So there is a 90-degree angle here that is not labeled. Label it if you want. Then there is also a segment KL in both triangles that's the same segment, so it's congruent to itself. So once you label the right angles and the legs, you can just check, and yes, they each have a hypotenuse that's congruent to the other, so this is an HL. Number 4 says, is HL going to work?
Yeah.
Okay, so I have the right triangles, right? Do I have legs that are congruent?
No.
Yep, you have.
Now I have legs. Do I have the hypotenuse? No. Now I will say these triangles are congruent, but it's by side angle side. It's not by HL, so this is still a no.
Wait, what's HL again?
What? HL, it has to be right triangles, same hypotenuse, same leg. So the hypotenuse would be across from the right angle. So we don't know anything about this side or this side. So this is not HL. What do I need if I want to use side, angle, side? And I'm actually going to go up here and show you. You are going to find what matches and trace the triangles. So here, what am I pointing to? Sides or angles? Side, angle. Okay, so what's missing? Yes. Okay. So you can put the tick marks on there and then describe them. Some of you just put like sides missing, or you would give me the wrong pair of sides, all right? You gotta be really careful and you have to write it in the correct order, okay? If you start at W and go down to U, you have to start at Z because those are the two that are corresponding, and go to X, all right? So get your fingers, put one on one triangle, one on the other, and trace it to see what's not there, okay? Any questions? All right, number 6. Side, side, side. So what do I have here? Side. Side. I'm missing these sides.
One side. It's a one stripe side.
So yes, you can put one tick mark on each, and then you write a congruence statement. So GE, if you start at G and go to E, you have to start at W and go to Y. These are segments, so put the segment symbol on the top. They need to be congruent, so put the congruent symbol on the bottom. Some people lost some points for notation yesterday too, okay? If it's a segment, it needs a segment label. If it's an angle, it needs an angle label. If they're congruent, I need the swoop, okay? Questions? Number 6, what additional congruence is needed? So I want to start at angle, angle, side, angle. So angle, where's the side? There isn't one, but here's the other angle. So what sides need to be congruent? F and L are angles. D. Hold on. I need, watch me trace it. I need angle, then the side in between the angles. So what side is between these two? What side is between these two? That's what I need. If it's if you pick the wrong side, that'd be angle, angle, side, which is not the indicated postulate. You have to go with what they're asking you for. Questions? All right, so the last one says, what do we need if we want to use HL? Now, a lot of you on the quiz would tell me something that we already know is congruent. So like in this one, a lot of people would put like XV is congruent to VX. We already know that. They're the same segment. So that is not going to be the answer. You're just telling me something I already know. Okay? So in order to use HL, what do I need? I need 2 congruent legs, right? These are the legs. So I have the L part of HL. I also need right angles. Do I have those? Okay, so what's the only part missing from the HL? The hypotenuse.
There's KB and WX. And the KB and WX.
K, V, and WX. Those are the hypotenuse. Yes. So again, I'm going to repeat this because it was really a problem for a lot of people yesterday. If it's the same... If it's the same segment in both triangles, you don't need to tell me it's congruent. I already know that. You should already know that. Feel free to label it, okay? The part that I am looking for is the part that we don't already know, but we still need to know. So yes, in this one, it would be the hypotenuse from each. So you guys described it as KV congruent to WX. That would be fine. I went the other way. So WX congruent to KV. All right? Any questions?